Okay, 1 through 6. Y'all be quiet. We're going to scoot through these 1 through 6, or you can solve it. It tells you any method. I'm going to solve them the way I would if I were working them. If you did a different way, that's okay. On number 1, x squared plus 12x plus 35 equals 0. This one is my favorite one because it's factorable. A times c, the factors of 35 that add to b, are 7 and 5. So this means this would be x plus 7 times x plus 5 is equal to 0. Now just set both of those factors. X plus 7 equals 0 gives me negative 7. And x plus 5 equals 0 gives me negative 5. If you did the quadratic formula, as long as you didn't mess up, you'll still get those same two answers. Okay? Everybody all right? We've been solving quadratics for 3 weeks now.
I know, I'm just saying.
Come on, Lennon. Where you been? We've been missing you. We haven't been complete in here without you. Well, every time you miss like several days. That's
No, I got
doctors.
checked out yesterday before the spirit to go get shots, and I got back there again.
Gotcha. All right, number 2 is like the bell ringer. I've got 3x squared minus 48 equals 0. If you choose quadratic formula, your b would be 0. When I don't have a b, I'm going to do it like I did on the bell ringer, and I'm going to solve it algebraically. So I'm just going to move that, isolate the x, move that 48 over. So I would add that, I have 3x squared equals 48. Then I would divide by 3, and that would give me x squared equals 16. Now I would undo the squared and square root, so x will be whatever this positive or negative square root of 16 is.
4.
Plus or minus 4. Okay, we good? Alright, 3. I've got x squared plus 10x plus 25 equals 64. If you chose to do the quadratic formula here, the first thing you would do would be to subtract 64. I didn't do that. I did this one by completing the square. Because I looked at x squared, that's a perfect square. I looked at 25, that's a perfect square. So I did my b check. I said, well, half of 10 is 5. If I square 5, it's 25. So that is the same as x plus 5 squared. Okay, you didn't have to do it that way. This is the least common way to do it. But now I can undo that squared by square rooting. So x plus 5 will have to equal positive or negative 8. Because the square root of 64 is 8. So now to solve for x, I got to subtract 5. So I got to do 8 minus 5 and negative 8 minus 5. So that got me 3 and negative 13. Whoa, she said.
I got negative 5.
You got your work still handy where I can look at it? Which one? You didn't subtract the 64 over.
I got 3 and negative 7.
See, you guys said it, we did a quadratic formula, you guys said it equal to 0,
Oh,
so you
yeah.
need to subtract 64. You got work I can look at?
Yeah, 2 and 3. Yeah, I got negative 3.
It says shallow.
Alright, so square root of 256 is not 4.
I
Well, you only go one time though, I think that's what.
Oh, okay. I think it went down to 16.
Yeah, so you'll do negative 10 plus 16.
Yeah, it was 16.
Correct.
Alright, number 4. 4, I've got negative 3x squared minus 5x equal 5. Alright, nothing was special on this one. Wasn't any perfect square stuff going on, so I was just going to be with you and do the quadratic formula. But before I could do the quadratic formula, I need to get it in standard form, so I need to set it equal to 0. So I'm going to subtract this 5 over. So it's going to be negative 3x squared minus 5x minus 5 is equal to 0. So we got an A of negative 3, a B of negative 5, and a C of negative 5. It's got x equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Alright, so that got me, I was looking to see where I did my work at, 5 plus or minus the square root of 25 minus 60 all over negative 6, and then 25 minus 60 was negative 35. And I heard lots of people getting that yesterday and then not knowing what to do because 35 doesn't have a perfect square in it, and that's correct. 35 does not have a perfect square, so 35 is going to stay underneath the radical, but I can't leave that negative underneath the radical. So what do you do when you got a negative?
You have to put an I.
Good job, Landon. So I'm going to have x equals 5 plus or minus I square root of 35 all over negative 6. And just leave it because it won't reduce any. You got it. Alright, number 5 I did the quadratic formula on. Everybody ready? I've got 4x squared plus 3x minus 10 is equal to 0. So my A was 4, my B was 3, my C was negative 10. So I had negative B plus or minus the square root of B squared minus 4AC all over 2A. So then that was 169 plus 160 is 169. Square root of 169 is 13. Okay. A lot of people are still confused about what to do when they get there, when the radical goes away. You just have to write two problems. You got to do negative 3 plus 13 and then divide it by 8, and negative 3 minus 13 and then divide it by 8. Negative 3 plus 13 is 10. 10 over 8, you can put that as a fraction or a decimal. I just reduced it to 5/4. Negative 3 minus 13 is negative 16. Divided by 8 is negative 2. Whoop, whoop.
So do you want us to put it in a fraction or decimal?
I don't care. Either one. I prefer fractions, but it's not wrong if you put 1.25. Alright, 6 is similar to the bell ringer again, like number 3, except you're going to get an I in it. I've got 36x squared plus 49 is equal to 0. Alright, so I don't have a B. My B is 0 if I'm doing quadratic formula. But I'm just going to go ahead and solve because I know something special about 36 and 49. They're perfect squares. So that might be an easy thing just to go ahead and solve. So we're going to subtract the 49. Then my x being multiplied by 36, so we're going to divide by 36. I don't know what 49 divided by 36 is. I'm just going to leave it. Negative 49 over 36. Now my x is being squared, so I'm going to undo that by square rooting it. So it's going to be the positive or negative square root of negative 49 over 36. When you square root a fraction, you square root the top and the bottom. This is why I chose this method here, because 49 and 36 are both perfect squares. So that's going to be 7 over 6. But what about the negative? What does the negative tell me I need? Ah, very good. My marker just froze.
Right.
So I'm going to have x equals positive or negative. And I had people yesterday writing the I in front of the 7/6. It's not wrong. If you do, it just looks weird. I just wrote all that and circled it and nothing showed up. Afraid I'll start writing and then it'll sometimes just appears. Oh, we're going to finish up there.
I get the bag for it. I do that. No, I thought he was going to do that.
Alright, so positive negative 7,6i would be our number 6 answer. Okay, had lots of questions all day long yesterday on 7 through 10. These are the easiest ones on the whole test, and there's a couple different ways you can do them. I'm going to show you the easiest way and then show you how to do it mathematically if you're just feeling like you got some extra time and want to do it mathematically.
I have a question
Yes,
about
ma'am.
that. If we put the I before it, is that
It's okay.
wrong?
No, it's not wrong. It just looks funny, but it's okay.
Okay.
Alright, we know that zeros or roots or solutions are where we cross the x-axis. So if we've got a parabola, we could have two real solutions. We could have one real solution. One that never crosses it has no real solution, which makes them be imaginary. So something that crosses it twice, you're going to write two real. Something that hits it once, you're going to write one real. Something that never crosses the x-axis, two imaginary.
So that's all
Okay?
real?
So look in there at number 7. What would you write on number 7?
Two real.
Two real. 8, one real. 9, two imaginary. 10, two real. Okay, the other way we learned to do this when we did it algebraically, if you're not given a picture of the graph, we did the part just underneath the radical. Remember that? B squared minus 4ac, the discriminant. We talked about that before, so it does give you the equation there if you wanted to check them and do it algebraically. If our discriminant was greater than 0, we had two real. If our discriminant was less than 0, we had two imaginary. If our discriminant equaled 0, we had one real. Remember when we did that a long time ago? Alright. Number 11 is an old problem. It has to do with Vertex. It says a golf ball is hit from the ground and its height's modeled by that equation where h of t is the height in feet of the ball t seconds after contact. What's the maximum height? So if we hit our golf ball, we're looking for that maximum height. That's at the vertex. Okay, so we have to find the vertex basically of this. We've got h of t is equal to negative 16 t squared plus 128 t when we're in standard form to find that axis of symmetry. Negative b over 2a. Been a while, but we've used that a lot. Okay, so we're going to first off plug our stuff in there. So I've got negative 128 over 2 times negative 16. What do you get for x there? 128 divided by 32 is what you're looking for.
Negative 32? Oh, no, it's negative 2.
Get 4, Chloe?
Yeah.
Because the negative by negative makes it positive. So I wasn't stressing over that. Alright, so we got 4. 4 is not your answer. That's the axis of symmetry. Now we got to take 4, plug it back in to figure out how high our golf ball went. Okay, so we're going to have negative 16 times 4 squared plus 128 times 4. That'll tell us how high our golf ball went. Do the 4 squared before you multiply by negative 16. Figure out how high the thing went. What? Woo.
But you have some people that multiply 16 times 4 and then square it.
Yep. All day long yesterday.
Does that throw it off?
Yep. What's the matter, Chloe? What'd you get?
Hold on, I think I did it wrong.
Right, negative 556 for the first
I
one.
got
Or
it.
256, not 5. Negative 256.
Okay. He's not done yet. He's saying his first part's that.
And the second part is 5.
So then add those.
I got negative 256.
For the whole thing?
No.
Okay.
It's 256 for the whole thing.
Oh.
So our golf ball went 256 feet high. You get negative 256 here. You get negative 256 here. You get 500 and something here. When you add that, it comes back to 256. Good deal? Everybody all right on that?
Oh, that was one of our things. Well, speaking oh, no.
Okay, 12 and 13 are both pretty easy ones. We ready? Alright, 12, we've got 1 minus I minus 4 minus 5I. Alright, directions on this, just say to write as a complex number in standard form. The i's in this case, we talked about this, are just kind of like terms. So I'm going to take my real numbers, 1 minus 4. Okay, then I'm going to take my imaginary numbers. Be careful with your signs. Negative I minus negative 5I. That's it.
Ha!
Oh, you did?
Yep.
What?
Is what I got. I can't remember
What is that number? Is that a 1? The first number.
One, it's on your sheet, bud.
Okay.
Alright, 13 we have to multiply, so we're going to do a little bit of FOIL.
But
I got negative 4 plus 5I times 5 minus I. So this is a binomial times a binomial, so I'm going to do my first, negative 4 times 5 is negative 20. My outer, negative 4 times negative I is a positive 4I. My inner, 5I times 5 is 25I. And my last, 5I times negative I is negative 5I squared. Alright, like terms. 4I and 25I, that's 29I. What's I squared the same as? Negative 1. Good, so it makes negative 5 times negative 1, which makes that a plus 5, right? Negative 20 plus 5, negative 15. Whoop, whoop.
yeah, we would have made Did you see that Parabola one? Yes, I guess.
Alright, 14 and 15 are probably two of the ones that would take you a little bit longer to do. On 14, when we're solving the system, we've got two parabolas on 14, don't we? Both things are squared. So that means that I could have parabolas that have 2 solutions, I could have parabolas that have 1 solution, or I could have parabolas that have no solution. Okay, this particular one is one that has 2 solutions, so we're going to get 2 answers on this. That second equation is already solved for y. So I'm going to take what y is and I'm going to substitute it in the y spot in the first equation. So I've got negative 2x squared plus, but instead of y, I'm going to write what the second equation tells me y is. X minus 1 squared plus 3, and then back up to the first equation equals 1. Okay, so with that x minus 1 squared, that means I have to write that twice and multiply it. So do that up here, x minus 1, that gets me x squared. Minus x and minus x is minus 2x, and then plus 1. Okay, now I've got a couple of spots that have like terms. That's negative 1x squared. That's 4. Okay, I've almost got it to a quadratic. I need to do what Stephen said and move that 1 over, so it's going to give me negative x squared minus 2x plus 3 is equal to 0.
It's set up now.
So we can do the quadratic formula. Is that all right? My a is negative 1, my b is negative 2, my c is 3, so I have negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's 4 plus 12 is 16, square root of 16 is 4. So I have to do 2 plus 4 divided by negative 2 and 2 minus 4 divided by negative 2. So that's negative 3 and negative divided by negative positive, so negative 3 and 1. Now don't just put that as your answer.
You have to plug it back up.
Okay, those are the x's. Remember I told you we're looking for 2-ordered pair. So I'm going to have a negative 3 something and I'm going to have a 1 something. So we got to plug those back in to find our somethings. I didn't write the equation down I want to use. The second equation. The second equation says y equals x minus 1 squared plus 3. Negative 3 minus 1 is negative 4. Squared is 16. Plus 3 is 19. Now I got to do the same thing with the 1. 1 minus 1 squared plus 3. 1 minus 1 is 0. So 0 plus 3 is 3.
Whatever it does right there.
I got everything to do here.
Alright, number 15. I got alright, same direction, solve the system. We've got a line and a parabola on this that we're looking at. It's not solved for anything. What we did in class when we had these, we noticed that we could eliminate the y's. These y's have same signs, so I'm going to subtract, but I don't have like terms matched up. So be careful here. I've got 0 minus x squared.
We got number 15.
Yep. I got 4x minus nothing. Negative y minus negative y is nothing. He gone. And then 4 minus negative 1. Okay. Move that 5 over. Okay, so now we're already ready for the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, we're just about done on this one. Because this is negative 4 times negative 1, which is positive 4. 4 times negative 5 is negative 20. 16 minus 20 is negative 4. I'm looking for the place where these lines intersect. What happened when we did this in class when we got a negative underneath there? When we're solving it, we do. But we're not solving. We're looking for where they intersect. So where are they going to intersect? It's like this case here. They're not, right?
They're not.
So what do we write for our answer on that?
Imagine.
No, we're not solving it. We're looking for the name of the place where they intersect. If it's imaginary, what kind of number is that?
0.
It's not 0. No
It's no number.
real solutions.
There's no solution.
You didn't know that. Be quiet.
I didn't think of the word.
I'm sure. I'm real sure. I don't get why it's that, but.
Because you got a negative underneath the radical.
It
It does if you're solving. But the directions weren't solved here. It was a system. It was more than one. If it was just one equation, yes, you would put the I. But when you got two, you got to write it differently.
That.
No real solution.
All right, 16 and 17, we have to scribble on our graphs. Let's get that ready. I'm going to graph that thing, first thing I would do would be to try to set it equal to y. So if I move that y over here, then I'm going to move the 5 over here. So I'm going to have 3x squared minus 5, and I can just say is equal to 0. Okay, now I've got it in standard form, so I'm going to do negative b over 2a. So that would be 0, because I don't have a b, over 6. So that means its axis of symmetry is going to be there. Plug a 0 back in. 0 times 3 is 0, so just have minus 5, right? So I'm going to go 1, 2, 3, 4, 5. Pick another x to plug in. Don't use 0. We already got a 0, so like 1 or a 2. Which one y'all want to do?
2.
1?
I said 2.
Let's do
2? 4? Oh, that's going to be big.
Let's do 1 then.
1 times 3 is...
1, that's good.
Okay, 1 times 3 is 3. 3 minus 5 is 2. So it'll be over 1 and up 2. Same place on the other side. I made that like the skinniest parabola I've ever made. Alright, we get something similar to that. The spacing on your paper, they counted by 2s, it looks like. So whatever, if you ever need to readjust the spacing they did, that's fine with me. Okay, we got to test our test point now to see if we scribble on the inside or the outside. So I'm going to use 0, 0 because that's on the inside. So I'm plugging that back into the original problem they gave me. 0 squared times 3 is 0. Y is 0, 0 minus 0. So is 0 greater than 5?
No.
No, Landon's correct. So I can't scribble 0, 0, which means my shading will be on the outside of the parabola.
Wait, how do you know
If your test point makes it true, you would color inside. Now I need to make one adjustment to my graphs. Anybody know what it is?
It's...
Need to make it right at all.
What?
I thought it wasn't right at all. I don't know.
What am I doing
You need to
here?
make it dash.
Oh,
Yep. It just had a greater than. It wasn't greater than or equal to, so it should have been dashed.
There you go.
I don't know what that means.
Hey, wake up and do your work.
We want you to succeed. That's what David said.
Those over the line.
Oh, 17. We got a line
Is
and
that the thing where you said on, if it's greater than 0, it's too rare? Is that thing?
You wrote in your head.
It's on there, so.
Right.
Alright, 17, we've got a line and a parabola intersecting. On the parabola, I'm just going to write it first. I've got x plus y squared. I know it's a parabola because it's squared. It's greater than 3. But it's the y that's squared. Usually in a parabola, it's the x that's squared. Since this is the y that's squared, it means it's going to be a sideways one. Okay, so I'm going to solve this for x. X will be greater than negative y squared plus 3. So I'm looking at negative b over 2a out of this stuff here. And again, I've got a 0 in my b spot. So that means my axis of symmetry, since I'm sideways, is going to be here. I plug a 0 back in. 0 plus 3 is 3. Oh, I've done that wrong, doofus. It's got to be on the axis of symmetry. 1, 2, 3.
At the head.
Alright, now we got to plug something into the y. So you could like come up here to 1 or 2 and plug a y. What do you want to do?
Yeah, I do that.
1?
Yes.
1. So I'm going to have something 1. 1 squared is 1. Negative 1 plus 3 is 2. So be 1, 2, 1. Put it on the same side. This time it's going to be dashed. I'm paying attention to what I'm doing this time, so I'm going to draw a dashed. Hey, that's pretty good. Alright, got to figure out where to shade on that one. So I'm going to use 0, 0, plug it into my original one. 0 plus 0, is that greater than 3? No, so I can't shade 0, 0, which means it's outside again that gets shaded. Kind of looks like I'm making a turkey.
What's
Alright, so that's just the first section.
just the first section?
Now we've got a second one. Negative 3x plus y is less than 1. Alright, that's just going to be a line because nothing's squared. I'm going to graph it using intercepts real quick. I don't, you would probably solve it for y. That's what y'all did most of the time in Algebra 1. If I put a 0 in for the x, my y is 1. If I put a 0 in for the y, my x will be negative 1/3 because I would divide by negative 3, right? Okay, I gotta figure out where to shade on that. I'm not touching 0, 0, so that'd be an okay one to test. Is 0 less than 1?
No, yes.
Yes, it is. So I need to shade 0, 0. That's below my red line. So I'm shading below my red line. So my answer on this is going to be everywhere where I have red and black.
Wait a second.
Wait a second.
I screwed myself. You screwed it up.
You screwed that bad boy up.
I know.
Wow, that's cool, bro.
So that ugly green mess.
No, I don't
Thank goodness there's only 2 of those.
Yeah. Oh my gosh, there's another color.
That color's the answer for it. Alright, 18's a pretty easy one. Get back on track here.
Did that turkey remind me of Thanksgiving?
Yeah, Merry Thanksgiving.
Quadratic, do you notice that every time one of them say something, they all attribute it? Like, Hunter said, I screwed that up. Dawn said, you screwed it up. And Lady said,
They share a brain.
yeah. He said, you screwed that bad boy up. Like, they all said the same thing.
Glass guys.
Alright, so 18. A company that produces video games has hired you to set the sale price. Gives you an equation there. It says P is the profit in dollars and X is games sold. What will the profit be if it sells 100 games? So you're just plugging 100 in for the X's on that. So you've got negative 0.3 times 100 squared plus 45 times 100 minus 1,000. Okay, anybody do that yet? Do it real quick. Test it.
That's a lot of money.
It's 500 should be the answer you get. They're going to make $500 if they sell 100 games. That doesn't seem like a very good business to me.
No.
100 games is a lot.
Yeah.
$5 a day.
Good thinking there,
That's
Clark.
like $60 in the real world. Yeah. Could be. Like, you make like $6,000.
Yeah.
Alright, on 19, you had to know the formula for the area of a trapezoid, and I'm going to give that to you. If there's a formula that you need for a word problem like that on tomorrow's test, I'll give you the formula, but this one was a trapezoid on 19. Are we ready?
I got 3,200.
Let me see what you typed in.
Like the thing.
I don't think that's right. Hit enter. You just 0.3, not 0.03. Alright, so the formula on 19 for area of a trapezoid is 1/2 times the height times what you get when you add your bases. Okay? I had to look it up. I didn't remember it. I don't use the area of a trapezoid enough to know that. Alright, I made me a little sketch about my flower garden as it told me. It says we're designing a flower garden in the shape of a trapezoid. So I just drew a basic looking trapezoid there. She wants the shorter base to be 3 yards greater than the height. So I named my height X. So this one will be 3 more than that. Then she wants the longer base to be 7 more than the height. So So 7 more than that. Total area of the flower garden is 150. What will the length of each base be? Okay, so first thing we have to do here is add our bases. So that's just combining like terms. That's 2x plus 10, right? So I'm going to have 1/2 times x, because that's my height, times x plus 10. Okay? Now.
Yeah, isn't it 2x plus 10?
Yes. Because x and x is 2x, yes. Alright, now if we distribute that 1/2x, 1/2 times 2 is 1, and x times x is x squared. 1/2 times 10 is 5. It's got 5x, and it said the area of this thing was supposed to be 150, is it yards or feet? What we do? 150 square yards. Okay, so here, once I'm almost to quadratic formula level, I need to move that 150 over. Okay, negative b plus or minus the square root, b squared minus 4ac
Nobody asked you.
all over 2a.
That's very good.
Will they be able to use this?
That got me 625 underneath the radical. And the square root of 625 is 25. Y'all check, make sure you get the math correct on that. I worked this yesterday. I'm looking at my notes. So I had to do -5 plus 25 and divided by 2. This one, I'm not going to work. Why am I not going to work that one?
Because it's negative.
And? That's right. Why does that matter here?
I don't know. I just kind of.
I'm finding dimensions of a flower garden.
And it
Oh,
Can't have a negative
can't have a
dimension on
negative
that.
dimension.
Okay, so -5 plus 20 is, or plus 25 is 20, and 20 divided by 2 is 10. Don't put 10 as your answer. That's just x. Okay, go back and look at our picture. If x is 10, this base would be 13, and this one would be, there's your two answers.
Why didn't he? Why didn't he square the 25 and put it in this quadratic formula?
Underneath here, I got 625. The square root of that's 25. I didn't show all my steps on that, I'm sorry.
That's your phone, Gary.
We got one more.
Why is it bring on the side?
Whatever.
It'd be 10.
X was 10, but then that made that 13 and 17 were our answers. Because our bases were x plus 7, so 10 plus 7 and x plus 3. Alright, start a basketball game. The referee tossed the ball vertically in the air, modeled by the equation -16t squared plus 22t plus 6. Determine the time interval in seconds in which the height of the basketball is greater than 8 feet. So I'm taking that equation that they gave me. I need it to be greater than 8. Okay, so now all I'm going to do is subtract the 8 to put this in standard form. So I'm going to have -16t squared plus 22t minus 2. I'm not going to mess with this right now. I'm just going to solve it like normal, so I'll throw the equals on there. Now, if you want to do the quadratic formula from here, you can. I'm looking at my paper when I did it yesterday, and I divided it all by 2 first, because I got my numbers a little bit smaller. So I actually divided it by -2. I'm going to do it that way. If you don't, it's okay.
Trevor, where's your spider bite?
Okay. Alright, so I'm in the quadratic formula now.
I hate my life. Due today at the beginning of her class.
I don't know what you're talking about.
What?
Alright, that got me then
They are.
121 minus 32. That didn't, shall be quiet, that didn't get me a perfect square, but it told me on this that I'm doing time and I'm rounding to the nearest thousandth. So it was okay to go ahead. I did 121 minus 32, and then second square root, it's 89 of 89. Nearest thousandths is 3 numbers after the decimal, so it's going to be 9.434. Okay, so I do have to do this twice because I'm looking for the time intervals. So I'm going to have 11 plus 9.434, enter, divided by 16, enter, 1.277. And then I'm going to do 11 minus 9.434, enter, divided by 16, enter, 0.098. So what that means is, in context to this problem, we were trying to find when the ball was going to be 8 feet off the ground, between that little bit of a second and a little bit more than a second. So you got a real narrow time window. If I wanted to write this fancy, the smaller number would go first. Look like that. Alright, you'll be able to use any notes on paper that you have on your testimony. You'll be able to use the study guide that you have. Won't be any use of electronics other than the calculators.